So, first two sections were just on factoring quadratics in general. We're going to look at two more skills that we need before we get to the next part. One of those is I want to highlight our special cases. We specifically have two of them. So the first one, I'm just going to demo with an example and then kind of showcase the pattern and see if we can use it as a shortcut. So, marked myself on the pen over there. Anyways, moving right along. So, suppose I gave you the following. I gave you x squared minus 16, and I asked you to factor that. And if you were to make your box, you would plug things into your box, you would make your diagonal, make your diamond, find the values you're missing, pull out your GCFs, and go through all of that. But we can jump straight to the fact that we know that this middle term is a 0. There is no 0x in the middle. And so you're looking for two numbers that multiply to a negative 16 and add to this 0. And it turns out that those two numbers that are going to work are going to be a plus 4 and a minus 4. 4 times a negative 4 is a negative 16. 4 plus a negative 4 gives me 0 for that middle term. And sure enough, I now have my two factors, x plus 4, x minus 4. This is a shortcut pattern, and it works like this. If your first term is squared and your second term is squared and they're being subtracted, then your pattern is just going to be a plus b and then a minus b as its factored form. And this strategy right here is called a difference of squares. And so anytime we see a perfect square subtract a perfect square, we can jump straight to its factored form. As another example, suppose I were to give you the following, and I gave you 4x squared minus 25. Well, it simply becomes a matter of, can I write these two terms as being perfect squares subtracted by each other? So for example, this minus 25 I can think about as being a 5 squared. I can rewrite that 25 as a perfect square. I can do the same with the 4x squared. I can group it together, and I can think about that as really being a 2x squared. So if you have a 2x squared and a 5 squared and you've subtracted, you can follow our blueprint that says, hey, add them and subtract them. And you're done. You're in your factored form. No box is necessary. So difference of squares is a really helpful strategy to shortcut some of our factoring problems. We have another blueprint we want to take a look at. So I could give you, I don't know why this pen is bleeding this much. One second. We'll see if that does any better. I don't think it did. Oh well. X squared plus 6x plus 9. If we were to factor that, we're looking for two numbers that multiply to 9, add to 6. Those two numbers, hopefully without much effort, you're going to realize are both 3. And so the fun thing with this one is now our two sets of parentheses, or our two factors, are exactly the same, meaning that you could write it as a perfect square. To follow the blueprints, same as we did up before, I want you to think about how these two 3's become what's in the middle. And it's a little misleading this time because of those 3's we have right there. I'm going to go ahead and show another example. Trying to think about how I want to do this. Give me 1 second. Yeah, let's go for it. I'm going to go ahead and show another example because I'm going to go ahead and throw an extra number in front of this x squared so we see the way the blueprint fits together. So if I come down here, 4x squared plus 20x plus 25. I'm just going to pass along that this one right here follows the same pattern as up above. I'm not quite ready to write it out in a blueprint form yet, but here's what I want you to realize. The first term, 4x squared, is a perfect square. The 25, 5 squared, is a perfect square. What we need to be careful of is make sure that this number in the middle still follows our pattern. And so here's what I'm going to hint at right now. The pattern that works for this is the following. If you have some blueprint right here, ax squared, and you've got the same thing at the ends. So now you've got a and b. That's a b. I'm going to call that good enough so I don't have to find my white out. So you've got an ax squared and you've got your b squared at the end. To get this middle term, it has to be 2 times a times b. So in other words, when we're looking at this problem up here, 4 means that this would be a 2x squared. 25 means this would be a 5. So if I took the up above problem, I would have 2x squared. This would become a 5 squared. So in other words, this pattern of 2ab is telling me that this middle term should be 2 times this first 2 times this last 5. And that all together, 2 times 2 times 5 is 20, which does check out with my original problem. So what that means is this. My factored form up here is going to be 2x plus 5 twice. 2x plus 5. And just to get the example down there, my blueprint then says ax plus b times ax plus b, which can be rewritten as a perfect square. This one has the name perfect square trinomial. I realize my way of going about this particular one was a little bit more haphazard, so I'm going to do another example from start to finish so that you've got the blueprint in mind and you see how the examples work with the numbers. So I'm going to see how quickly I can come up with an example right now. Let's go 9x squared, and let's throw on a plus 16, and let's do a let me think. Let's go negative 24x. So I'm throwing in the extra layer of putting that negative sign in there as well. So let's take a look at this problem right here. First up, my first spot is a perfect square. That 9x squared can be rewritten as 3x squared. My second spot, I've got that 16. That 16 can be rewritten as a 4 squared. I need to check to see whether these numbers fit to make that middle term. And that middle term is going to be made up of my blueprint by a 2. It is going to be made up of the number in front of x, which is a 3. And it is going to be made up of the number at the end, which is a 4. And if I multiply that 2 times 3 times 4, I do in fact get 24. However, I needed to count for the negative sign. So I don't want a positive 24, I need a negative 24. So one of these numbers has to be negative. Well, the 2 definitely isn't going to become negative. What that leaves me is the choice to make either the 3 or the 4 negative. And let's think about this for a second. If this 4 right here were really a negative 4, if I square negative 4, don't I still get positive 16? So sure enough, I can make that one negative. Now, could you have made the 3 negative? Yes. However, as a convention, or a rule in mathematics, we tend to keep the x's positive if we can. So it will be favored to make the 4 negative, though if you threw the negative sign over here, that's not wrong, it just looks different. So if I take this all together, I'd be able to jump straight to my answer, which is going to say 3x minus 4. And we're going to write that down twice. And those are your special cases for factoring.